Okay, folks, in this tutorial, I want to show an approach to take an assembly made of several parts and do a quick and dirty way of estimating the response of that assembly to certain load and boundary conditions. Now, uh, I refer to this thing as a quick and dirty estimate because there's a lot of unknown things that have to be addressed here, and we are making certain assumptions that may or may not be realistic. So here is the situation. Suppose we have an assembly made of these three parts, and we know that this assembly is subjected to, for example, an applied pressure on the top. This side face is calm, and that side face is calm. And we want to know what is the response of this assembly as far as stresses go to the particular condition. You might say, well, there's not enough information here. In other words, how are how are the parts in this assembly interacting with each other? For example, is this vertical column, is it welded to the bottom plate? How about the top one? Is that vertical column is welded to the top plate, or is it just let it sit there so that as the load is applied, then it slides? For example, this vertical column's top face slides along the bottom face of this cube. Well, we don't know these things, so a quick and dirty way of estimating in a very uh, conservative way is to say, okay, let's say that this assembly was, in fact, all the parts were tied together, okay? And of course, if that is the case, what you can do is you can create an analysis connection between the appropriate faces and then make them fasten, for example. That's fine. There's nothing wrong with it. But another approach is to say, okay, you know what? Why don't we convert this assembly into a single part and then pretend that that single part, which is shape of this assembly, maybe casted like that, maybe machined like that, is subjected to this load. What is the response of that single part? Okay. Uh, Please note that there are many ways of doing this problem, and the one that I'm showing you is one particular approach. Since dimensions are not important here, we just randomly go ahead and make some things that look like that, and then proceed with the problem. Let's start with an assembly, which is a product. And we're going to insert our first part here. Again, the dimension totally irrelevant. So I'm going to, let me change the color here, tools, options. Okay, very good. So I'm going to insert my first part, insert a new part in there. And that's going to be the bottom plate. Double click on it. Let's make it. On that horizontal plane, I will sketch, for example, a rectangle like this. Totally ignoring dimensions here. Exit, oops, exit, and then pad it. So that's my first part. Then I'm going to insert, go all the way to the top, insert a new part. That's going to be part number 2. I'm going to make it. So my import design, yes, no, not yet. So on that face, I will sketch a circle, exit, and then pad it. Let's make it a little bit bigger, so maybe 0.1. Oops, 0.1. Okay, go all the way to the top, insert our last piece. So insert a new insert a new part. Okay, and this will make it. So on that top face, for example, I'll sketch. Okay, so maybe something like that. Totally irrelevant as far as dimensions go, because I'm just showing you the approach. And up. Let me make this thing a little bit taller so that you can see it better. 0.04. Okay, good. So all the way to the top. Okay, let's to make my job easier, let me assume that everything is made out of steel here. So what I'm going to do is I will go to uh, apply material, and on that entire assembly, I'll use I don't know, steel, and then say okay. Very good. Okay, so what I want to do is now convert this thing. First of all, let me do a file save management. File save management. Save as. I have a folder, July 12. Okay, I'll put the stuff in there and then say okay. So in that folder, I have that product and then 3 parts. Now, we go to tools and generate cat part from product. You click on it. Okay. It says select the part that you want. Let me cancel that. Try it again. Okay. So tools, generate cat part from product. New part number. New part number. So why don't I call it new? Actually, let me select this. It puts a default. It puts a default part name here, right there. See that? The default. Now I don't have any bodies, but so it doesn't matter whether I check this or not. I'll check it, and then you say okay, and there we are. Now, if you go to that folder, July 12th that I had, let's see if I can find it, right there, you see that you have your product, and you have part 1, part 2, part 3, but I don't have this new product that was created, new part that was created. This is a part. So let's do a file save management to save it there. File, save management. This one that was created new, save as. I'll give it the same name. So in the same folder. Okay, and then say okay. Notice that now if I go to that folder, I have my part 1, part 2, part 3, my product 1, and another part which is called product 1 all cat part. Okay? All right, good. And notice what happened here is actually part body, there's nothing in it. Okay, if I try mesh this thing later on, it's a part. But if I try to mesh it, it's not going to work. So what I'm going to do, I'm going to take all of these things and put it in there. And to convince you, let me show you what happens if I go to generative structure analysis. If I go to generative structure analysis, it takes that all cat part and then say okay. And then when you try to mesh it, notice it didn't mesh anything. And when I try to mesh it, if you click on this, you won't be able to pick any of these guys. Okay? Nothing. You won't be able to pick anything. That's because, let me kill that. That's because there's nothing in the part body here. So what I'm going to do, I will use the Boolean operation. If you don't have it, go to tools. You go to tools, not tools, view, toolbar. Make sure that the Boolean operation is checked here. And where is it? Boolean operation is, see, it's checked. That's why you get it. And then add these these things to the part body. Okay, so go here's add, Read it carefully. It says add this to the part body. Another one, another add. Select this. It automatically adds it to part body. I don't have to select the part body anyway. It's going to automatically select it. Notice as things are moving up. And another add. Select this. Automatically it's going to be added to the part body. There we are. And in part body now you have stuff. Dumb solids basically. So now when I go to generative structure analysis, it says material was not applied because I applied it to the assembly. It did not go through. No problem. No problem. Close that. But a mesh will be created. It doesn't have any material. Okay, it doesn't have any material. But I can do that now. I can do that right now. So let's go and apply. By the way, we can see our mesh. Let's look at the mesh. There we are. And in fact, if you go and look closely, you see that the node numbers from the pieces are the same from this plate and from that. They're the same, 81, 82, etc. And the same thing up there. So it did actually measure. It's just that the property is not correct. So can I delete this? Yeah. And then I'm going to do that myself. So whereas I'm going to first define a user. See that user material? Click on user material. And we're going to choose metal, and we're going to choose steel, and then we say okay. All right. And now we're going to apply 3D property. It says where is your user material? Where is the material? The support is that mesh. The material is that user material is the one that I created. This one, properties of steel, and then we say okay. All right. Good. So let me deactivate this and proceed with the rest of the problem. We are told that this end is clamped and that end is clamped. These are two clamped ends, clamped faces. And we are told that there is a pressure on the top here. Whatever the value is, these numbers mean nothing because I'm just ignoring the whole dimension. Now we're going to run it. Quick and dirty analysis, because we don't actually know what the interaction between these parts are. So we assume that everything is made of the same part. So here's a deflection. You can animate it. Close. You can look at the deflections. There we are, etc., etc. You got to be very careful because we basically made the assumption that these pieces were all completely glued together, completely fastened together. And as I said, you could have created a connection between these parts and made it fasten, and it would have been very close to this. But I wanted to show you how you take an assembly, convert it to a part. But then, in order to measure it, you have to. This one way is to add all these uh, things that are created into the part body, and then go ahead and do it. Now, in the meantime, notice that material property was lost, so I had to go and create a user-defined material, and then apply 3D section into that using that user-defined material. All right. Good luck if you ever need to do this.